All right, this is the second video in the inscribed angles and properties of chords. Here, your learning objective will be to understand three important conjectures about chords and apply those conjectures to specific circles to solve problems. The three conjectures we're going to be looking at are chord arcs conjecture, perpendicular to a chord conjecture, and chord distance to center conjecture. After I introduce each of those conjectures, there will be an example. So first, let's look at the chord arcs conjecture. That states that if two chords are congruent, two chords in a circle are congruent, then their intercepted arcs are congruent. So here in our circle, we have two chords that are congruent. So we know that their intercepted arcs are congruent. So that arc must be congruent to this arc. And let's give them labels. I'll give this A, B, C, and D. So what we then have is that the measure of arc AB has to be congruent to the measure of arc CD. That's the conjecture. In this example, we have line segment BO is congruent to line segment AT, and we know that the measure of this arc is BO. I could also say here that remember that an intercepted arc, since that arc is 80 degrees, we know that this angle right here is 80 degrees as well, because the central angle relates to the arc in that way. And here, this angle must also be 80 degrees, and that is the measure of arc AT. So according to the conjecture that we just learned, because these two line segments BO and AT are congruent, their intercepted arcs must also be congruent, and their intercepted arcs relate to their central angles in the sense that they are equal. All right. The perpendicular to a chord conjecture states that the perpendicular segment from the center of a circle to a chord bisects the chord. So in this statement, the perpendicular segment from the center, so this segment is perpendicular to this segment, as marked right there. So it goes from the center. It must bisect the chord. Bisect means it creates two congruent parts. So this side is congruent to that side. So if we want to label this, we can say that AC is congruent, that segment is congruent to segment BC. And let's look at the example. We have a segment from the center of the circle. It intersects a chord at a right angle. That means that this segment, AF, is congruent to segment CF. So segment AF is congruent to segment CF. And since AF is 7, the measure of segment AF is 7, the measure of segment CF must be 7. Since we're looking for the length of segment AC, it's going to have to be 7 plus 7, which is 14. And then it's units. We don't know what the units are on this situation. That's our example for perpendicular to a chord conjecture. Our final conjecture is the chord distance to center conjecture. So that says that two congruent chords in a circle are equidistant from the center of the circle. So here we have two chords, chord AB that is congruent to chord CD. And I'm going to mark these with colors that make it clear what I'm suggesting. So we have chord AB is congruent to chord CD. That's the two congruent chords in a circle. They're equidistant from the center of the circle. That means that from the center here, the shortest distance between that center and any part of the segment AB has to be the segment that is perpendicular to the line. So similarly, from the center to segment CD has to be the segment that is the shortest distance is the segment that is perpendicular to it. And so then what we have is a situation where EF must be congruent to EG. Segment EF must be congruent to segment EG. And that is the part that is equidistant, that segment from the center to the nearest point on the segment. So in our example, here we have, again, these two chords that are congruent, and it should be marked here that they are congruent. So let's mark that. So in the setup of the problem, it must be the case that line segment QR is congruent to line segment ST. Otherwise, we can't say anything. But once we know that those two chords are congruent, that means that these two segments must be congruent because they are perpendicular to those chords. So we can write an equation, 2x is equal to 5x minus 9, and solving for x, I'm going to add 9 to both sides, get 2x plus 9 is equal to 5x. Subtracting, fix that a little bit, subtracting 2x from both sides, we get 9 is equal to 3x. finishing this up by dividing by 3, we get x is equal to 3 units. So we could, we're looking for the length of CU. So CU is, that segment's right here. It's 2 times x. So we have 2 times 3 is equal to 6 units. And that is the length of CU. Hope that this makes clear these 3 conjectures that we've looked at. Have a good day.